Have you ever imagined that the entire universe we know might be inside a black hole? This surprising theory, proposed by some of the brightest physicists of our time, has the potential to completely transform our understanding of the cosmos. The film Interstellar fascinates audiences by exploring the idea of traveling through a black hole. The protagonist, Cooper, faces unimaginable challenges as he attempts to escape a black hole. Although the film is a work of fiction, it is based on real scientific theories to create an engaging narrative. Many scientists believe that anything sent into a black hole would be destroyed by the intense gravitational force, being spaghettified in a process called tidal stretching. However, there are new discoveries suggesting a different view. Some recent studies indicate that passing through a black hole might not be as fatal as previously thought. Instead of being completely destroyed, matter could be stored or even sent to another point in spacetime. This idea is fueled by the theory that black holes could be portals to other universes, offering a fascinating new perspective on the nature of the cosmos. These theories lead us to reconsider our understanding of black holes. If black holes can indeed store or transport matter in a way that defies our current comprehension, this would have profound implications for physics and cosmology. Let's now explore how the 20th century brought great surprises to our understanding of the universe and how these discoveries have shaped our modern view of black holes. The 20th century was a period of revolutionary discoveries that changed our understanding of the universe. One of the most significant milestones was Albert Einstein's theory of general relativity, which replaced Newton's theory of gravitation. Einstein proposed that gravity is not just a force but a curvature of spacetime caused by the presence of mass and energy. This idea transformed our view of the universe and paved the way for many other discoveries. General relativity not only explained the orbit of planets with greater precision but also predicted phenomena such as the expansion of the universe. In 1929, Edwin Hubble observed that galaxies are moving away from each other, indicating that the universe is expanding. This discovery led to the acceptance of the Big Bang model, which suggests that the universe began from an extremely dense and hot state. General relativity also predicted the existence of black holes, regions of space where gravity is so intense that not even light can escape. These discoveries of the 20th century redefined our understanding of the cosmos and laid the foundations for modern physics. The idea that the universe is in constant expansion and that black holes are a physical reality changed the way we see our place in the universe. As we explore further, the notion that the universe may have originated from a black hole in a larger universe becomes an intriguing possibility. Let's now examine this fascinating theory and its implications. The theory that the universe may have originated from a black hole in a larger, parent, universe is an idea gaining attention among scientists. This theory suggests that new universes can be born whenever a new black hole is created. In this scenario, the black hole in our universe would be the gateway to a completely new universe, with its own physical laws and initial conditions. This fascinating idea arises from the understanding that black holes are more than just sinks of matter and energy. Inside a black hole, conditions are so extreme that spacetime can be distorted in unimaginable ways. Some scientists propose that the central singularity of a black hole, where density is infinite, could be the starting point for a new Big Bang in another universe. This would imply that the birth of a universe could be a relatively common event in a broader multiverse. This theory also offers a new perspective on the Big Bang and what might have existed before it. Traditionally, many physicists believe that there was no before the Big Bang, as time began with it. However, if our universe is the result of a black hole in a larger universe, this suggests that our Big Bang was merely a transition from a high-density state to the expansion we see today. This view opens up the possibility that our universe is just part of an eternal cycle of creation and destruction of universes. Traditionally, the Big Bang is seen as the starting point of our universe, the moment when all mass and energy were concentrated in an infinitesimally small and extremely dense point. This singularity gave rise to a cosmic explosion that resulted in the expansion of the universe as we know it today. According to this view, time and space began with the Big Bang, and there is no before that we can conceive. However, some theories suggest that the origin of the universe may be more complex. Some scientists propose that all the mass and energy of the universe were compressed into an extremely dense point inside a black hole. This idea suggests that the Big Bang was not the absolute beginning but a transition from a high-density state to the expansion we currently observe. This view challenges the idea that time began with the Big Bang and suggests that our universe may be part of a continuous cycle of creation and destruction. If this theory is correct, it would imply that black holes in our universe could be portals to the creation of new universes. Each black hole could contain a singularity that, upon reaching a critical density, triggers a Big Bang in a new universe. This leads us to reconsider our understanding of time, space, and the nature of reality. Instead of a unique and isolated event, the Big Bang could be part of a broader and cyclical process. This perspective also raises new questions about the fundamental structure of the cosmos and how universes might interact with each other. The idea that we are inside a black hole suggests that the universe could be much more interconnected than we imagine. The idea that the core of the universe, similar to a seed, could have formed inside a black hole is an intriguing theory that challenges our traditional understanding of cosmology. In this scenario, all the mass and energy that make up the universe would be concentrated in an extremely dense and small point, an environment so extreme that only a black hole could provide. This dense core, under the right conditions, could trigger the creation of all the particles, galaxies, and living beings that make up the universe. Imagine a black hole as a sort of cosmic nursery. Inside it, gravity is so intense that matter is compressed to a point of almost infinite density. This extreme environment could generate the necessary conditions for a new universe to emerge. The seed of the universe, contained within the black hole, could then expand, starting a new cycle of creation. This implies that the universe as we know it could have begun as a singularity inside a black hole in a larger universe. This theory not only offers an explanation for the origin of our universe but also suggests that new universes could be constantly created. Every time a black hole forms, it could potentially contain the seed of a new universe, perpetuating an infinite cycle of creation. This vision transforms our understanding of the cosmos, suggesting that the universe is part of a much larger and more complex multiverse. When we talk about black holes, we cannot forget to mention Stephen Hawking, who made one of the most revolutionary discoveries about black holes by revealing that they are not completely black. In 1974, Hawking proposed that black holes emit radiation, now known as Hawking radiation. This radiation causes black holes to lose mass and energy over time, eventually evaporating completely. This idea challenged the traditional view of black holes as eternal and indestructible entities. Hawking radiation introduced the concept that black holes not only absorb everything around them but also emit particles. This creates an interesting paradox about the loss of information. In quantum physics, information about the initial state of a system must be preserved. However, if a black hole completely evaporates, where does the information it contained go? This information loss paradox has been one of the biggest challenges in theoretical physics, leading to intense debates and new theories. One of these theories is the holographic theory, which suggests that the information within a black hole is related to its surface area in 2 dimensions, rather than its volume in 3 dimensions. According to this theory, all the information contained in a volume of space can be represented as a hologram on the surface that surrounds it. This idea is inspired by the fact that the entropy of a black hole, which is a measure of its information, is proportional to the area of its event horizon, not its volume. These revolutionary ideas from Hawking and the holographic theory have transformed our understanding of black holes and the nature of information in the universe. This leads us to explore the concept of the event horizon and singularity and how Einstein's theory struggles to describe extreme forces within a black hole. At the heart of black hole theory are 2 fundamental concepts, the event horizon and the singularity. The event horizon is the boundary around a black hole beyond which nothing, not even light, can escape due to the intense gravitational force. This is the point of no return. Once something crosses the event horizon, it is destined to be pulled into the center of the black hole. Within the event horizon, gravity is so strong that all known laws of physics begin to break down. At the center of the black hole lies the singularity, a point where density is infinite and spacetime curves infinitely. Einstein's general relativity equations predict this singularity but also fail to describe precisely what happens at this extreme point. This is because, at the singularity, gravitational forces become so intense that classical concepts of space and time lose their meaning. Einstein's theory struggles to describe these extreme forces because general relativity does not integrate well with quantum mechanics, the theory that describes subatomic particles. This disconnect between the two main theories of physics, general relativity and quantum mechanics, is one of the greatest challenges in modern physics. To fully understand what happens inside a black hole, especially at the singularity, scientists need a unified theory, often referred to as quantum gravity. These difficulties in describing the extreme forces within a black hole lead to new and fascinating theories. Calculating the mass of the entire observable universe and comparing it with the mass of a black hole, it was discovered that the Schwarzschild radius of a black hole with the mass of the universe is almost the same as the size of the visible universe. This suggests that the characteristics of our universe may be similar to those of a black hole. If the universe is inside a black hole, this implies that we are living within the event horizon of a giant black hole. This event horizon would be the boundary that defines our universe, beyond which we cannot observe or experience anything. Within this cosmic black hole, the laws of physics as we know them apply, but in a much broader and more complex context than we imagine. This theory offers a new perspective on the origin and structure of the universe. One of the most intriguing implications of this theory is the idea that our universe might be just one among many, each contained within its own black hole. This would lead to the conception of a multiverse, where each black hole creates a new universe with its own physical laws and initial conditions. If this theory is correct, our universe would be just a small part of a much larger and more complex reality, full of black holes that are gateways to other universes. This vision challenges our understanding of reality and opens new possibilities for scientific exploration. The idea that we live inside a black hole suggests that black holes are not only destructive but also creative, being responsible for the generation of new universes. This transforms the way we see the cosmos and invites us to explore more deeply the wonders of the universe. The theory that the universe might be inside a black hole challenges everything we thought we knew about the cosmos. From the concepts of black holes presented in science fiction to the scientific revolutions of the 20th century, we have seen how each discovery brings us closer to a deeper and more complex understanding of the universe. The idea that our universe might have originated from a black hole in a larger universe offers a new perspective on the Big Bang and suggests that we are part of an eternal cycle of creation and destruction of universes. We have explored the notion that the seed of the universe could have formed in an extreme environment like the interior of a black hole and discussed how Hawking radiation and the holographic theory transform our understanding of black holes. The relationship between the event horizon, the singularity, and the theory that our universe is inside a black hole opens new possibilities for science and invites us to reconsider the nature of reality. If this journey into the unknown has sparked your curiosity, don't forget to subscribe to the channel and turn on notifications. Keep following our videos to explore more about the incredible secrets of the cosmos and the discoveries that can transform our understanding of everything. Until next time.